Good afternoon and good morning, everybody. Thank you for joining us for our webinar on lighting needs for cannabis in the state of New York. We're going to be talking about a few things today relevant to the subject. So you're going to hear a lot about how cannabis grows and the lighting requirements for the crop. We're going to touch on the New York regulations, and then we're going to give you Griffin's best solution for getting started as a new cannabis grower in New York. We're going to start today with our partners from Signify. We have Colleen O'Hara, Key Account Manager, and Martin Borima, Plant Specialist with Signify. And they're going to get us kicked off. Thanks so much for joining us, Colleen and Martin.
Thank you, Tammy. Thank you, Griffin, for having us today. Good morning and afternoon, all. Happy St. Patrick's Day. I don't have green on, but like we said, we'll see a lot of green today, so that's a good thing. We're going to dive in right now and talk more about the Philips lighting side. So I believe we'll have some Q&A at the end, so please hold your questions. There's also a Q&A chat box, so if you have any questions, please feel free to post them in there, and then we'll get them answered by the end of this presentation. So yeah, Martin and I are here today. Martin is a plant specialist with Philips. I'm a key account manager. I've been with the company for almost 2 years now. We're going to get into our agenda and discuss the history of Philips lighting, choosing a site for your cannabis cultivation, either greenhouse or indoor facility, horticulture lighting definitions, some crop stages, and talk more about photo periods, why LEDs work for cannabis, an overview of our LED options, and then dig a little bit into rebates in New York. All right, so let's talk about the Philips lighting journey. Philips has been around for 130 years. So we've been in the business. We started with lamps in the late 1800s in Eindhoven. We were just there actually this fall. We were able to see, the city of Eindhoven it's right outside of Amsterdam. That's kind of where Philips lighting started. So we've been around for a very long time. And I think that leads into when we got into the actual horticulture business. And that happened, as you can see, 1891 is when we started. In 2007, we established our horticulture team. And then in 2018, we formed our global cannabis segment. So you'll see just the progression of where we've gone and where we started. And we not only work in cannabis, we work in all different types of crop situations. So I like to just start with thinking simple. Plants need lights to grow. Cannabis needs the most light to grow. Whether we'll get into more supplemental lighting from a greenhouse perspective, but we really want to dig in, try and make this as simple as possible for you with understanding horticulture lighting. So just a few quick things. Some of you might have real estate already acquired. Some of you might still be in the early process of acquiring and looking for a site. So just keep these considerations when looking for a site. We always talk about, I think zoning is the number one. Is the site zoned for cannabis cultivation? That's really easy. We understand that that's probably the most important piece of finding a place to cultivate. Does it have an opportunity zone? So in New York, there's opportunity zones that have been identified. Is the community involved? What's their involvement in having cannabis in that area? And that goes hand in hand with municipality support. What are their tax rates? Do they have support of local utility? It's really important. I think power and water, really making sure that you have both of those things when looking for your site. And then once you see the site, if it's an indoor facility, you want to worry about ceiling heights, ventilation, insulation. Will it have proper security? And then you want to make sure that you have plans for growth. So if I start with a micro license and I want to keep increasing that space, is there availability for growth? Because you don't want to have to pick up and move your facility. So I'm going to pass it over to Martin. Martin's our plant specialist. We work in a triangle here at Phillips. So we have myself, the key account manager, you'll always have a plant specialist, and then we have an application engineer. So that's a triangle that we work in at all times when we're talking to growers. So Martin's going to talk really quickly about some of the classifications and some of the definitions that you'll have to understand when looking at horticulture lighting. Martin?
Yeah, hi all. Can you hear me
Yep, you're good.
properly? Okay, good. So yeah, and in general, we can split up lighting in supplemental lighting, which is in greenhouses that are already receiving solar light. But as you know, cannabis is a light-loving crop, and even in the summer, you could make a case for adding supplemental lighting year-round. And then, of course, we have a lot of new companies or even heritage companies that are growing sole source indoor. And that is, we are also specialized in sole source only lighting. So, of course, we're going through the basics of light. A photon is a particle of light, and one photon will excite one electron in the chlorophyll, and so that is a one-to-one. Photosynthetic active radiation is the light, like the solar light we receive is a large amount of light, but only within the visible light, pretty well, 400 to 700 nanometers. The plant actually utilizes the light for photosynthesis, and that has to do with the absorption of light by the chlorophyll. Moles.
I think that's really quick, Martin. It's really, when I started and to educate myself on lighting, those photons are, that light is releasing all of these photons. And a colleague of mine used to say, never waste a photon. So making sure all of those photons that are coming off of your light, what's hitting the actual plant itself. So that's what PAR is what's actually hitting between that 400 and 700 nanometers. So just trying to make it clear as possible, because this stuff is very confusing. But Martin, yeah, let's discuss moles kind of next.
Yeah, moles are, it's Avogadro's constant, right? It's the number of moles, and one mole is 6 times 10 to the 23rd photons. Okay, so one mole of element is also the same. So it's across the board moles. And then next, micromole is a millionth of a mole, and that's how we measure photon flux. And so photon flux is measured in micromoles, but the daily light integral is the total amount that has fallen down on your plants or has been absorbed by your plants on the total daily crop cycle or photo period. Okay, so it's moles per day, and again, that is a number times the moles. Okay, the total amount of light that the plant has received over a day.
Yeah, so we might ask you, what DLI are you targeting? So that's a great question to understand is, what DLI are you targeting at your greenhouse to hit that number of photons that you need to be hitting on your plants. So just a measurement of light. Let's talk about these last few. Again, these are, I think, even more confusing sometimes, but we'll try and explain them as best as possible.
Yeah, ppf is it's like having a water hose, right? How much water comes out of the hose? How much light is being emitted from a light fixture? Okay, so while ppfd is how much light hits the plant on a known area. Okay, so if you spray an area of plants with a hose, the amount of drops of water would then that hits the plants actually the same idea as pulses are produced by the fixture per watt per second or joule in micromoles per joule. Okay, so that number running from, let's say, 1.9 in HID HPS lights to over 3.5, 3.8 in the most modern LEDs.
Yeah, so you want to find, obviously, we all want efficient items. So whether your refrigerator is efficient to, you want to make sure those lights that you're purchasing are as efficient as possible to keep those bills down. So let's get into some photo periods, and we know the phases of growth, obviously, but let's discuss, and the duration. Obviously, this is dependent on what light, and there's different parameters that that duration is based on. We're able to speed up the veg phase with different recipes of light, same with propagation. But Martin, why don't you just talk more about the photo periods, like hours versus day, and that range of DLI that we're shooting for?
Yes, with propagation, if you like, there's a broad range mentioned here, 8 to 20 days, but we have special recipes that minimize the amount of time and maximize the uniformity of rutting. Okay, so we have our special recipes. Also, our efficient white has shown to be more effective in vegetative phase. I have a grower who had 2 veg rooms, and one smaller than the other, but he could turn the small veg room into production because this spectrum promotes like a quick vegetative phase turnaround. Okay, so in the flowering phase, growers like to grow between 32 and over 40 ppfd. There's our DLI. There is a trend to go more and more and higher, but I think we can show you ways to make your DLI go further, and also grow more with less DLI. And of course, mothers, they are the same as veg, and they also produce stronger and more vigorous clones if you use the right type of spectrum.
Great. So really it depends on, again, some parameters, but typically those ranges are what we like to see for our DLI in those different phases of growth. So next we're going to just talk about LEDs for cannabis cultivation. We have lights that grow tomatoes and leafy greens, but we're going to dig in right now to cultivating cannabis, putting light over cannabis. So technological advantages of LEDs. Why are we seeing so many adopters of LEDs? Well, we're using A-grade LEDs. Those use 70% less electricity. That's I think the biggest takeaway that we see is we take away that less electricity to produce the same amount of illumination. So when you see your bills, you're going to be happy. They have much longer lifetimes. You're not changing out lamps. They're, most lights that you see out there have a 3 to 5 year warranty. They should last much longer than that. There's minimal heat. So we know that HPS lights give off a ton of heat. So we're able to control light and heat separately. They're very easy to clean. You can take one down, you could take a rag and go right down them. Most of them should be IP66, which means they can have water hit the light as well. The spectrum, so we talk a lot about spectrum, that's optimized for the best cannabis crop growth. And then there's obviously more light output options for greater flexibility. So you see different outputs for different stages of growth. And each light has a different responsibility from our portfolio. So Martin, let's talk about plants using lights that we cannot see. So sort of left to right, what does a human eye see versus what plants see?
Well, these graphs kind of represent the sensitivity curve, okay, of the plants versus the human eye. For example, the bottom left is the human eye sensitivity curve that peaks in the green yellow and is lower in the red and the blue. And the plants, they peak at around, in the blue at the 450 and between like 600 and 700 in red. Okay, so to be as efficient as possible, you have to respond to the plant sensitivity curve with your lighting spectrum.
Great. And let's talk more about what the actual LEDs, what were they target?
Yeah, so if you can you go back again?
Yeah,
Yeah.
sorry about that.
So in the background again, you see the solar, right? Like the large graph in the back. It's more the solar, and if you see the in the middle, you see the HID or the HPS light output, which actually corresponds with the human eye sensitivity curve. Like HPS lights were really parking lot lights. And that if you look at our spectra, they correspond with the sensitivity curve of plants, chlorophyll A and chlorophyll B. And so it still is a broad spectrum because there's still white and green and yellow in the spectrum, but it is being absorbed much more efficiently by the pigments, by chlorophyll.
Yeah, I think you look at it like HPS lights, they're not targeting what plants want to grab. They're still getting the photons that they need, but is it the right amount? So I think just seeing this graph, graphs are sometimes confusing, but if you look at it from a red and blue perspective, the LEDs are giving the plants the food that they need to grow. Okay, let's move on here. If my mouse would work, sorry about that. All right, so let's talk about producing lighter heat. What are our lights actually producing? This is a graph basically that shows, heat is expensive, only pay for what you need. Let's pay for our energy costs, but are we paying also to push the heat out of our facilities and our greenhouses? So you'll see this graph from the left to right. You'll notice the LED versus HPS, really see it from this red perspective, that radiation heat. So you'll see that 10% versus an HPS light that's giving that 55% off. So that energy balance is really off from an HPS perspective. And as you can see from your left side, we're just trying to balance that out. Okay, so we're not, heavy heat, more light. We're trying to really just flatten that curve. Martin, I can explain this too, but uniform lighting leads to uniform growth. You'll notice on the left-hand side, it's missing a lot of uniformity. So as you can see, these spots, these are some hot spots of where there's more light hitting the canopy than others. As you can see here, you're a lot more uniform. So when you're looking at lights, just making sure that that uniformity number is at the level that you need. Typically, we like to see it above 80%. So just make sure that your uniformity is good. And if you get a light plan, you could see it also from this type of graph where, you'll see good uniformity versus poor uniformity. Really important to make sure that when you're growing that you're really uniform across your crop. And then how does spectrum affect growth? Really interesting stuff of like what blue does, what red does. You see these lights and you're like, I wonder why all these different colored diodes are in my light. So blue on the one hand affects morphology. How compact do you want your plant? Your pigmentations, your stomatal activity. From a red perspective, your elongation, your morphology, that side, your flowering and germination. So different diodes affect different things within the plant. And then typically white, this is our human preference. We work under white light. So you'll notice that most LEDs that you look at will have some type of white in there, but the more red and blue, you'll be a lot more efficient. So when you're looking and when you're shopping around for lights, I like to just discuss from an outsider's perspective what to keep an eye on and what to look through. I mean, these are just some of the claims that are out there. Unbelievable yields. We lead with science. We have thousands of diodes. You'll see all these different things in the market. And awareness is everything. Longevity is really important. How long has the company been around? Will they be around in 3 years? We've seen a lot of exits, and I worry about warranties. So who can you trust? The failure rates are really important. So ask the manufacturer that you're talking with, what's your failure rate? How many failures will I have if I'm going to be buying 500 lights? Also making sure support. I mean, any product that we buy, we want to make sure there is full support. So are we selling a light or are we selling a solution? Are we educating you on how to use LEDs? We have some manufacturers have one size fits all, making sure that these customers are willing to talk about their experience. We're listening to them, and then we're bringing back a recommendation of what we think is going to be the best for them. And again, what research is being conducted, what specific support is offered, and then are they doing some calculations and helping you with energy cost, your return on investment, your heat loads, etc. So it's if it sounds too good to be true, I always say it probably is. Hype is good, but substance is better. So just be aware of those things. And every light should have a baseline spec sheet. So when you're looking at that spec sheet, you'll see obviously length, width, height, your weight. Weight's important when you're having to install these lights. Just make sure that that weight is comparable. Your voltage of your facility, your beam angle. You'll see your warranties, IP ratings are important, IP66, and some of these others. So let's get into our next slide here. So really quickly, don't want to spend a lot of time on the portfolio that we have, but we have a fixture recipe for every stage of growth from prop to flower. We've been doing all different types of studies since 2018 on cannabis. Right now, we have a few going with inner canopy light, with propagation lighting results where we're shortening the propagation side. We're able to, where states don't have the rooting hormone, they're not able to use it. We're able to switch around the recipes of that spectrum to really boost and, like Martin says, start off like a rocket ship and go. I always take that quote from him, and obviously shorting the veg side. So top lighting compact, you see at the top left, this is, we call it our TLC, up to 2650 micromoles, 780 watts. These typically would go in a greenhouse, the top lighting compact or the top lighting linear, depending on your height of where you're hanging those lights. The grid lighting is typically for a racking style system. The production module is really used in propagation right now. That spectrum is dynamic, which means you can increase the red, you can decrease the blue, you can increase the white. So you have sort of a drag and drop software system where you can change the spectrum around. Really good for R&D as well. Inner lighting is your inner canopy lighting. If anybody wants to see some studies we've done on that, please feel free to reach out. And then flowering lamps. And then just when you're, we kind of really discussed some definitions, some things to look out for, how to see light when you're looking at it from a cannabis cultivation perspective. There's also a great amount of rebate opportunities in New York. So right now in New York, there's some grants that can be greater than 60% of your equipment cost. So please, when you're looking at LED lighting, make sure that you're able to get a quote how much money that you can see from your utility company. So you'll see National Grid, NYS Electric and Gas, Consolidated Edison. They're offering really strong incentives. But lean on us if you need that, Griffin and Phillips. We both can put you in the right direction to look into those utility rebates. We have in-house companies that do it for us. So really important if you want to make that jump to LED, to look into those rebates in New York. And here's some of our handles in social media. Again, you can find us on LinkedIn. Reach out to us, any questions you have, we would love to help you out. Thank you so much. I'm going to pass it over to Scott now.
Thanks, Colleen. Before we jump in with the information Scott's going to share, are there any questions? Is there anything on the chat panel, Mariana? I think we're good. I'm looking at it. So what we're going to do next is we have Scott Baker. Scott works special projects for us at Griffin, and he's working with new cannabis growers in New York. Scott is going to take the information that Colleen just provided and took us through, and he's going to show you how you can put this to work in a setting in New York in the way that we think is a really great starting point for everybody who's just getting into this. So Scott, thanks so much.
Thank you, Tammy, for the introduction. And thank you very much, Colleen and Martin, for your presentation. It was very informative. We appreciate that. Thank you. So a little bit about myself. I've been with Griffin Greenhouse Supplies for 30 years now. I'm the project manager for Griffin. Our team has been working on cannabis projects for about, I guess, since 2015. We work on warehouse projects, greenhouse projects, pretty much anything to do with cultivation of cannabis, recreational, medical, and hemp. So we do have a lot of experience. We've run into a lot of light applications, a lot of light vendors, a lot of LED companies. So we have seen a lot out there. So we get started. Okay, so solutions for New York. We go to the next slide, please. So when we do projects in all of the states that we work in, we try to make sure that we have a complete understanding of the regulations that each state has set forth. And New York State, we've had some gray areas. We don't have a lot of conclusive information, but what I want to go over here in a little bit is what we do know. And we know in the original regulations, applicants were allowed to use up to 20 artificial lights during the production of cannabis. We've recently heard, after working with a few customers, that there's been some modifications to that. We haven't found that in writing, but we have heard that applicants are now allowed 6,200 square feet of canopy in the greenhouse under lights, with another 12,000 square feet outside in field production. So we haven't confirmed that, and it appears to be a couple of counties that have told us this. So we're not quite sure on that one yet. We have also heard that is also county specific, that photoperiod light on mother and vegetative plants are not considered in the canopy calculation. The canopy calculation is only for flower. Again, we haven't confirmed that, but that's what we know. Also in the regulations, there is there is a provision where you can use existing horticultural lighting, but it definitely would have to be upgraded to have no less than 1.9 UMols efficacy. So that's something to keep in mind as well. Our interpretation of this, first of all, we are going to defer to your OCM agent. In every case, what we're hearing is the agent works very closely with you on the actual light plans, layouts, all that. So that confirmation would have to happen. But our interpretation, and some of its assumption, is that now that our interpretation on the 20 light maximum rule was really we thought it was more for the state to say, you know what, we're going to allow you to grow your mother stock, your clones, and raise your liners for the field. That's kind of what we felt when we first saw that limitation of 20 lights. It wasn't enough to do supplemental lighting on flowers. That's how we kind of read that. So we were kind of happy to hear that there might be an alternative option at the 6250 square feet under canopy. That kind of changes things a little bit. And with those assumptions, that photo period control utilizing non-fixed equipment was not considered lighting. We kind of put our focus on supplemental lighting just for flower. A good plan. Typically, when anybody approaches us about lighting a greenhouse, lighting any crop, doesn't have to be just cannabis. There's a couple things that we like to get across, and the most important one first, in my mind, is the transmission through the greenhouse structure, through the glazing, and it's important to know if you want to build a brand new greenhouse today with clear glass, you're probably only going to get 80% transmission. And that's kind of important to know, especially when you're comparing the DLIs with what the light plan is going to be. And the reason that is because the sun doesn't always come at that direct angle into the greenhouse. There's a lot of reflection and bounce off. That incidence angle and transmission are worse in the mornings and evenings, obviously, when the sun's going up, the sun's going down. So that's your lowest power. We do a lot of retrofits in greenhouses, and we see a lot of greenhouses that need to be converted from old ornamental greenhouses to cannabis greenhouses, and some of them can be pretty old, and glass, polycarbonate, those coverings can get really old, dirty, degraded, and you could lose up to 30, 35, 40% of that transmission. So also an important factor. You can see in the pictures here that infrastructure inside the greenhouse also causes a lot of shading, causes a lot of problems. So counting that bright thing in the sky is not as automatic as you might think it would be. Very important that the higher the mountain height for your fixtures, the better the light transmission. You're going to get more uniformity, and you're going to require fewer fixtures as well. Then the most important one is, if you're going to consider lighting, you have to make sure that you have enough electricity on site. It sounds funny, but it does happen where a current facility is either maxed out, or a new facility just doesn't have the capabilities to bring that much power in from their grid. So it's something that you really want to check out. We've included a little information here on the light transmission and why it is so important and how it can degrade. We've got a nice video here that you can look at. It's only a few-minute video, actually a very good video. And then we have an article that we've included. So I came at this as a project manager, and and the applications that we've seen in New York. And I kind of narrowed it down to 2 fixtures. I'm going to talk about 3 here that are in the portfolio for Phillips. And the first one is the Top Lighting Compact. And the Compact is really a very, very nice fixture. Full spectrum. It's a fixture that we use when we have a grower that wants to replace a high pressure sodium. It is definitely a 1-for-1 replacement. It operates in the 4-volt ranges that are shown. It's passive cooling, which means it requires a lot less maintenance. No fans, no input, no outputs. And the internal driver is not exposed to the elements, which we like a lot. We're not crazy about those drivers being out in the sunlight. You'll see some manufacturers that internal driver or power unit is actually separate from the unit and hangs by itself, which also blocks light. So very, very important that this is a slimline light. Lightweight and small footprint, only 23 pounds. You heard Colin, you mentioned that earlier. You really need to consider the amount of weight that you're putting into the ceiling of your greenhouse. Very low profile, 9.5 by 28 inches. Very, very nice light. Easy install. I think we like that probably the best of all. They have multiple brackets. The brackets can attach to the truss strut. They can attach to a C channel or unistrut, as we call it. Very, very easy to hang these. Also very easy to clean. The reflective white powder coated housing, easy to wipe down. Glass covered diodes for the maximum protection, which is nice. And we don't really recommend it in this application, but these can be dimmed using the GrowWise control system from Philips as well. I won't get into that too much, but it is a nice feature that if you want to further explore that, we could do that. What we did here is we did a light plan. As much as we like the TLC, the compact unit, it's a really, really nice unit. The limitations with the compact unit is that it really needs the height. It really needs to be mounted 14 feet, 14 or more. And it's hard to use in a low profile house. If you're 10 or 12 feet under your deprivation fabric, then this is probably not the light for you. But I wanted to show it because we like it a lot. And it's good for big, larger applications. On the right-hand side, you can see what we've done, a light plan for a full acre at a 14-foot mountain height. And I made a mistake on the left, but on the left, we just tried to take a cross-section out of that to show you what you would need for a single bay 24 by 100. It would require 4 rows of 16, not the 16 rows of 4 that I showed here. My mistake, my bad, but you get the idea. So we would have 4 linear rows in that bay, and that's where we would use that. So 14-foot gutters or higher. The top light and linear, or the TLL as we call it, the benefits of that are pretty extraordinary. I think this is probably, most of the applications that we run into, this is probably the light of choice, and for a number of reasons. Very versatile fixture, works at the lower ambient light and lower light, excuse me, and it also is conducive for the lower mountain heights that we're running into. Horizontal light uniformity for uniform growth. Again, it operates at 4 volts. Typically in the cannabis, we're working with the 277, 347 volts, the higher output models. This is a real reliable fixture, extremely low maintenance. We like it a lot because of the slimline design, 2 inches by 32 inches, and it only weighs 7 pounds. The installation options, again, the brackets are really unique, but this fixture can be used as a single fixture, or it can be used as a continuous figure. In other words, it goes end to end to end. So you can make it 64, another 32, and another 32, and you can add it end to end. Or we have the interconnect cable where we can go up to 6.5 feet connecting those lights, depending on what the light plan is calling for. It's available in many different recipes for optimal growth based on what we're requiring in the light plan. This fixture, the TLL, has dimmability capabilities. down to 10%. Again, it would have to be worked with the GrowWise control system. It is definitely something worth exploring, especially when you're dealing with months where you've got plenty of DLI and power outside versus when you don't. So it is something to consider if you want to control some energy and some light levels. Because this, as I mentioned earlier, this is probably the fixture for most of the applications that we're running into because of the low profiles. We asked Philip to just do a couple quick examples just to give you an idea on what they were talking about earlier with uniformity. Colleen and Martin were talking about the uniformity and the importance of the distance of the mountain heights. So the first one we asked them to do is we asked them to do a ground-to-ground greenhouse, a 30 by 96 ground-to-ground greenhouse with 30-inch benches inside with a mountain height of 11 feet. And to be fair, that mountain height of 11 feet is stretching it. That would be tough to do in a ground-to-ground, but it can be done. And we did this one specifically for veg, just to give you an idea. So veg plants growing on that 30-inch bench. You can see the uniformity isn't as uniform as we'd like to see it, but again, it's a veg plant. It's acceptable for what we've done here. The next plan shows the same greenhouse structure. Same greenhouse structure, but now we're doing flower. And the flower, you can see the uniformity has increased because we've gone from 6 rows, which we had in the veg, to 8 rows here, and we've added a couple more lights. So our uniformity has picked up, even though we're at the same mountain height. This is, we asked for a third plan in a Gotta Connect greenhouse, also with 30-inch benches, also with 11-foot mountain height. Again, we know that a lot of these, most of our Gotta Connects are 12 feet or less, and we have to account for the blackout. So in this one, you can see the uniformity is a lot greater. What I do want to point out is your uniformity is always perfect, dead center, but you'll notice that your outer bands, they start to degrade a little bit in uniformity, and that's because you don't have the overlap from the other lights. So you're always going to run into that, but you want to keep those bands to as much of a minimum as possible. Now, in the light plans, we'll use this one for an example. The veg is 4 rows of 24. We need 96, and the flower is 6 rows of 24. We need 144 fixtures. The first thing that we usually get once we show that is 144 fixtures is a lot of fixtures. If we could go back one slide, Mariana, please. One more to the uniformity, thanks. So if you see the star there, if you remember earlier, we were talking about the different volts, and we were talking about the interconnect and how they can daisy chain together. Most of the applications we see are 277 volt. When you're operating 277 volt, we can have 17 fixtures on one circuit. So you're not looking at as many outlets as you are fixtures. So that's kind of an important factor, and it's one of the reasons that we like this. As we mentioned earlier, ease of installation also comes with ease in labor cost, and the less money you spend on an electrician, the better off you are. The more that you can do with in-house labor, the better off you are. Thank you. Next slide. This is the third fixture in the portfolio. We don't talk about it a lot in the cannabis arena. It really is. It is a great option for your clones. If you want to use this on your clone rack, we would highly recommend it. Also works with the GrowWise control system, so you can play with your recipes as well. We probably wouldn't see that in cannabis clones, but it's something that you would consider in the vertical farming for lettuce and herbs, things like that. It's in 4-foot version, 5-foot version. It's definitely worth taking a look at, same as the GrowWise control system. We kind of fell in love with that. Again, I won't spend too much time. It really, I think Peter's on the phone. If you talk to Peter, Peter would tell you he likes to recommend this for the facilities that ask us for the R&D rooms, where they want to do a lot of research and development. They want to be able to play. They want to be able to go from different spectrums, different light intensities. They'll use this for that, and it does have a place. We have played around back and forth with some of our indoor grow facilities of using one light in one room to do veg and flower without moving the plants. So there is a place for it. There is a future for it. Definitely worth looking at, but it's hard to justify the CapEx. Wanted to touch on this because we'd be remiss not mentioning it to you. We're running into this more and more all the time. We're definitely seeing it in the food production, especially in the lettuce arena, where they're combining the high pressure sodium and the LED grow lights. And most of the stuff that you hear and you read, it's a comparison. Why is one better than the other? Back and forth, back and forth. And to be honest with you, in our mind, they both have their place. And they're, the high pressure sodium has its challenges. You can go on with the maintenance, the replacement of the bulbs, the longevity, the heat, all of that. We look at it a little bit differently. The lettuce facilities, for example, look at the technology, look at the high pressure sodium they're really looking at it for the heat source, and they're looking at the LED for the full advantages of the spectrum control. And some of the greenhouses that we look at for retrofitting already have some existing lighting, and typically it is the high pressure sodium. So we'd be remiss not to suggest a light plan checkerboarding the LED with the high pressure sodium. And we also think that we haven't studied in depth. We'd have to work with Phillips on it, but we think the rebates would still be applicable here, using a partial changeover with the indication of another changeover after that. I'm sorry, I'm losing my voice. So that brings us to the next slide, where we get this quite a bit, I guess the easiest way to put it is typically we get, well, what would you do if you were us and you had a license? And this is about new builds now. Okay, we are looking at a lot of retrofits, which makes a lot of logical sense, and we will continue to do that. And we wouldn't deviate from the retrofit. But if you had a license and you didn't have an area to grow in, and you really wanted to think about what we've said here, our first recommendation, as much as we love the Gutter Connect greenhouses, they're not CapEx friendly, and they're also they need to be maintained year round heat wise. There's a lot more maintenance when you're dealing with the Gutter Connect. So in our minds, our best recommendation is always to start small, first of all. So we would always start with a small frame, and we would recommend a 30 by 96, with the hope someday that you would probably get to 3 or 4 of these, maybe even attach them to your head house, production house. We work on stuff like that a lot, where it looks almost like a finger. So you have your head house and you have 3 or 4 fingers that come off of that. And with that structure, we would do an external roll up. So keep the roll up on the outside, keep the weight out of the trusses, and give us as much space as possible to hang those lights. And in this case, we would definitely recommend the TLL, the 4 rows, the 8 rows in this case, on a 30 by 96, the 8 rows of 23 lights, 184. Remembering, you don't need 184 outlets. you need 11 to 12 outlets. In this case, I would probably do a center double outlet of eight double outlets, excuse me. In this method, and this is a very, very simple recipe, and I'm sure there's many growers on here that would argue with us on this recipe, but we think it's the bare minimum to handle 30 by 96. We strongly recommend growing on the floor first. We've had great success growing on the floor. There are times when you wouldn't grow on the floor, but we prefer to save the CapEx for the lights and the fertigation, the irrigation, and obviously your cooling. Putting interventions on that infrastructure, the CapEx doesn't make sense to us, especially when you're only really gaining 30 inches. Now you have something else to clean. So we recommend typically growing in the ground. We typically recommend 7-gallon plants on 9 square foot centers. And that usually puts us in the 250, 260 plant range. And that accounts for a 4-foot aisle down the center and a 4-foot walkway on either ends for workspace. So it is tight. And we're using the most space we possibly can. But by doing that, it would allow you eventually to have 2.5 flower houses if you wanted, or 3 flower houses with better space. We know to do the 265 plants, we need a minimum of 10 to 12 mothers. And, we allot 12 square feet for them. They obviously have to have a separate area. So about 150 square feet for them. We know we're looking at about 300 vegetative cuttings to make sure that, we're going to have some skips, misses, and make sure we have enough to fill the 250. And then obviously more cuttings for the exact same reason, just so that we can call out the bad ones. This is just an example, but I was just talking about what we would recommend to you. This is an en-wall, which has high sidewalls. You can see those sidewalls, the gentleman walking down, which allows us to get those fixtures up to that 14-foot height. 12 to 14 foot, if we could, would be ideal. We count on 11. Good structure, heavy duty frame, roof vent on the right. And again, we would put the outside blackout, roll up blackout. Similar structure. You can see the cross struts, the vent at the top, and this is actually a really good setup for doing the TLL, doing those 8 runs. You can easily use the other strut on top of those cross trusses. So the application would be pretty straightforward here. Just an example of an on-wall oval tech, like we were just showing with the exterior light depth from Advanced and Alternatives. So this manually or automatically rolls up. There's a motor here, so this one's automatic. Rolls up to the roof, to the center beam when not in use. And I believe that's it for me. We can take questions, Tammy.
Thanks, Scott. That was great. It's such an elegant solution, and I love your ideas about starting small and growing the business. And you give a nice path forward to do that. So that's very well thought out. Thank you very much. We've got a few minutes. If we've got anybody on the call that would like to ask Scott or Colleen or Martin any questions, we also have a few other Griffin folks on the line that are also very knowledgeable in cannabis production. So feel free to drop your questions into the chat pane, or we could even, if you want to raise your hand, we can unmute you as well. Thanks, Fred, for posting. We are really appreciative of you being with us today. Sounds like everybody will want to go to the Q&A section instead of the straight up chat pane. All right, Scott, I think you guys and Scott, Colleen, and Martin, I think you did a great job. We are going to post the recording and we will get a copy of handouts to everybody who is on the call today. And then you can follow those links that Scott had on his presentation and dig in a little bit more. But thanks so much. We appreciate your time. Thanks to our speakers. And we look forward to helping everybody in New York. Happy St. Patrick's Day and have a great weekend.
Thanks all.
Thank you, everybody.
Nice being here.